Good day, everyone. I want to explain the Weierstrass substitution method for evaluating integrals. Okay, please, for you to be notified whenever I drop new videos, I would like you to subscribe, turn on the notification button, and then you can also share this video for others to see. Okay, the Weierstrass substitution method makes use of the substitution u equal to tan x over 2. Okay, with this substitution, it implies that if we have a right triangle, all right, a right triangle, it means that our angle is x over 2 and the opposite is going to be u and the adjacent is going to be 1, so that tan x over 2 will be opposite over adjacent, so that is tan x over 2 equal to u. So with this, we can obtain the hypotenuse by the Pythagorean theorem, which is going to give us 1 plus u squared. You know that the hypotenuse is the square root of the sum of the square of the other two sides. This enables us to obtain the definition for sine x over 2 and cos x over 2 as well. So it means that sine of x over 2 will be opposite, which is u divided by the hypotenuse, which is 1 plus u squared. Okay, and then cos x over 2 as well will be adjacent, which is 1 over hypotenuse, that is 1 plus u squared. Okay, but our interest is to get expressions for sine x, cos x, tan x, not sine x over 2, cos x over 2. So we can make use of the trigonometric identity. Recall that sine, let's say x over 2 plus x over 2, so that is like saying sine a plus b is going to give us that is sine a cos a, okay, plus sine a cos a, and that will give us 2 sine x over 2 cos x over 2. Okay, same way for cosine, cos x over 2 plus plus x over 2 will also give us, that is cos a plus b also is cos a cos b minus sine a sine b. Okay, for sine, that is a plus b. What we have is sine a cos b plus sine b cos a. But recall that our a and b is the same here, which is x over 2 x over 2. That is how we got 2 sine x over 2 cos x over 2, and then cos x over 2 plus x over 2 will give us cos squared x over 2 minus sine squared x over 2. We can substitute the values of our sine x over 2 and cos x over 2. So it means sine x over 2 plus x over 2 is sine x. So we have sine x is equal to 2 sine x over 2, which is u divided by 1 plus u squared, then times cos x over 2, which is 1 over square root of 1 plus u squared. And then evaluating this, we're going to get 2u over that's 1 plus u squared. When you multiply numerator and the denominator, you obtain sine x to be 2u over 1 plus u squared. In the same vein, cos x over 2 plus x over 2, that's cos x. So cos x is also equal to cos squared x over 2, that is cos x over 2 squared. So write 1 over square root of 1 plus u squared, that is squared. Okay, that is cos x over 2 squared, then minus, so that is u over square root of 1 plus u squared, then all squared. So evaluating this, we are going to obtain 1 over square root of 1 plus u squared squared, okay, minus u squared over 1 plus u squared. And then evaluating this, we obtain 1 minus u squared over 1 plus u squared. Okay, so this gives expression for cos x. So it is easy to get other trigonometric functions, say sec x, which is 1 over cos x. We just give us the inverse of cos x, and then we get 1 plus u squared over 1 minus u squared. For cosec x, okay, cosec x, which is the inverse of sine x, so we take the inverse of this sine x, that is 1 plus u squared over 2u. Tan x is sine x divided by cos x by definition, so which means we are dividing 2u over 1 plus u squared divided by cos x, which is 1 minus u squared over 1 plus u squared. So evaluating this, if you change this to multiplication, you see that this will go, so we're going to have 2u over 1 minus u squared as the value for tan x. So it means that the cot x will now be the inverse of tan x, and then we are going to obtain cot x to be 1 minus u squared over 2u. So if you need any of these values in your problem, you can easily use any of them. But let us do something, because we are dealing with integral, we are supposed to obtain value for the dx. If u equal to tan x over 2, then we can differentiate u to obtain the value for the x. So let us do that here. We have u equal to tan x over 2. Okay, so if we differentiate du with respect to x, you get sec squared x over 2, and then differentiating x over 2, we're going to have 1 over 2. So this gives the expression for the derivative of u with respect to x, and this implies that we have the u dx equal to 1 over 2. We can write sec squared x over 2 as 1 plus tan squared x over 2 by the trigonometric identity. Okay, so it means that the u dx is going to be 1 over 2 into 1 plus, recall that tan squared x over 2 is u. Okay, so we have u squared in that regard. So it means that our dx, if we make the dx the subject of the formula, we're going to obtain that will give us 2 over 1 plus u squared du. So this is our dx. Let me give an example for application. Suppose we are to evaluate integral of 1 plus sine x dx. So this is a very good application because Weierstrass substitution method helps us to evaluate with ease rational functions that involve basic trigonometric functions. So we can apply our substitution here. We have that our sine x is 2u over 1 plus u squared. So we can have this as integral of 1 over 1 plus 2u over 1 plus u squared. Then our dx is 2 here, that is 2 over 1 plus u squared du. So evaluating, we are going to have, let us simplify this, or let us unify this fraction. We are going to have integral of, or that is 1 plus u squared plus 2u over 1 plus u squared times 2 over 1 plus u squared du, and then we can write this as integral of 1 over, this is quadratic, and we can write it as 1 plus u squared, okay, over 1 plus u squared, then times 1 over 1 plus u squared du. So this will give us, if we take this inverse, we get integral of 1 plus u squared over 1 plus u all squared times 2 over 1 plus u squared du. So this takes care of this, and we are left with integral of okay, this is a constant, 2 can come out, so we have 1 over 1 over 1 plus u squared then du. This is just like a polynomial, so we can easily evaluate this because we can write this as 2 integral of, that's 1 plus u raised to power minus 2 du, and then evaluating this integral is easy. We have 2 into, that's 1 plus u raised to power minus 1 divided by minus 1, isn't it? And then if we differentiate 1 plus u, you get 1, so we have no problem. So plus c, what we have is minus 2 over 1 plus u, okay, and then plus c. Recall that our u is tan x over 2, so we can return that. That is minus 2 over 1 plus tan x over 2 plus c, and that is our result. You can see how we play around the Weierstrass substitution method to obtain the values for the trigonometric functions, and how we use that same method to evaluate this integral. It is good to note at this point that there exists equivalent answer for this particular problem if you apply another method. So the answer you get may look different, but they are equivalent results. So other method can give answers, I think, tan x minus sec x, okay, plus c. I may discuss this particular method in another video. So you can get tan x minus sec x plus c as an alternative solution, but using the Weierstrass substitution method, you're going to obtain minus 2 over 1 plus tan x over 2 plus c as your result. Kindly click like, share, and turn off the notification button for you to be aware when I drop new video. Thank you.